Assalamualaikum and hi to everyone who watching this. So today our group will be presenting about fuel cells. So the definition of the electrochemistry is the area of chemistry that studies how chemical and electrical energy can be converted. Relevance: system for energy conversions and storage, including fuel cells, batteries, and electrolysis, depend heavily on electrochemistry. Overview of fuel cells. A fuel cell is an electrochemical device that produce heat, water, and electrical energy from the chemical energy of an oxidant and a fuel.
Hi, my name is Ryan Idlan. Today, I will be explaining the principle of a fuel cell, which is an important technology for clean energy production. This slide outlines the electrochemical reaction that take place in a fuel cell. A fuel cell operates by combining hydrogen and oxygen to produce electricity, water, and heat. This process is based on an electrochemical reaction, which I will now break down into its key components. First, we have the anode. At the anode, the fuel, typically hydrogen, is applied. Here it undergoes an oxidation reaction, releasing electrons. These electrons flow through an external circuit, creating an electric current. Next is the electrolyte. The electrolyte plays a critical role by allowing the flow of ions between the anode and cathode. This is essential for maintaining the function of the fuel cell. Finally, we have the cathode. At the cathode, oxygen is supplied and it reacts with the electrons from the external circuit as well as hydrogen ions from the electrolyte to form water as a byproduct. The overall reaction can be summarized with the equation shown at the bottom. Hydrogen reacts with oxygen to produce water and energy. This is represented as 2H2 plus O2 and the product is 2H2O. In summary, a fuel cell is an efficient way to generate clean energy using hydrogen and oxygen. This technology has great potential for reducing carbon emissions and powering a sustainable future. In this slide, you can see types of fuel cells. I'll be talking about the various types of fuel cells and their applications. Fuel cells are an important part of the clean energy transition, and each type has unique characteristics that make it suitable for specific applications. The first one, we have proton exchange membrane fuel or PEMFC. We use PEMFC in automotive and portable power application. Second, we have alkaline fuel cell or AFC. We use AFC for space applications. Thirdly, we also have phosphoric acid fuel cell or PAFC. We normally use PAFC for stationary power generation. Next, we also have molten carbonate fuel cell or we simply call MCFC. We use MCFC in large-scale stationary power plants. Finally, we have solid oxide fuel cell or on other name we call it SOFC. We use SOFC in large-scale power generation. As you can see in this slide, every type of fuel cells has its own strength and limitation.
How fuel cells work and their components. Fuel cells are innovative devices that generate electricity by combining hydrogen and oxygen, producing only water and heat as byproduct. A fuel cell has three main parts: the anode, the cathode, and the electrolyte membranes. These work together to create clean and efficient energy. How fuel cells work? At the anode, hydrogen gas enters and is split into positively charged protons and negatively charged electrons by a catalyst. The proton pass through the electrolyte membranes while the electrons are forced to flow through an internal circuit, generating electricity along the way. Meanwhile, at the cathode, Oxygen from the air reacts with the protons and the returning electrons to form water as the final byproduct. The entire process also releases heat, making it highly efficient energy. To summarize, fuel cells work by separating hydrogen into protons and electrons, generating electricity in the process. The protons, electrons, and oxygen then combine to form water, leaving no harmful emission behind.
The advantages of fuel cells. Fuel cells are highly efficient because they use electrochemical reactions to directly convert chemical energy into electricity. Avoiding energy losses from combustion, they can achieve an efficiency of up to 85%, making them much better than traditional systems. Environmentally, hydrogen fuel cells are very clean, producing only water as a byproduct, unlike combustion engines that release CO2 and harmful gases. This makes them eco-friendly and supports sustainable energy goals, like the planned ban on gas cars by 2035. Lastly, fuel cells are versatile and scalable. They can use various fuels like hydrogen or methanol and power everything from small devices to large power plants. They are adaptable to vehicles, power grids, and even off-grid systems, making them suitable for diverse applications.
While fuel cells are promising clean energy solution, they face several challenges that hinder their widespread adoption. Some of the challenges are fuel cells are expensive to produce. Many require noble metals like platinum as catalysts, which are costly. Additionally, advanced materials such as specialized membranes and stack components further increase manufacturing costs. Second, the global hydrogen production and distribution network is not yet robust enough to support large-scale deployment. This is especially problematic for transportation, where fueling infrastructure is essential for widespread adoption. Third, durability and reliability remain significant concerns. For instance, proton exchange membrane (PEM) fuel cells can suffer from issues like membranes drying out and catalysts degrading over time, particularly at higher temperatures. Finally, fuel cells face intense competition from other energy storage technologies like lithium-ion batteries, which are rapidly becoming more affordable and widely used, especially in electric vehicles. These challenges, high cost, infrastructure limitation, durability issues, and market competition highlight areas that require innovation and investment for fuel cells to achieve their full potential as a clean energy solution.
So now, I will discuss the application of fuel cells in three major components. There is transportation, backup power system, and aerospace. Starting with transportation, fuel cells power hydrogen-based vehicles such as cars, buses, trains, and trucks. Their system rely on a membrane coat and catalyst for operation. Fuel cells offer similar performance to diesel engine in terms of operational range and load capacity, but with zero emissions. Additionally, the control system balances operation between the fuel cell and the battery, ensuring efficient performance. Next, for the backup power system, fuel cells are important for applications requiring high reliability, like data centers, hospitals, and telecommunication facilities. Companies like Microsoft use fuel cells to maintain operations during power outage. In hospital also, they are very important for keeping life support systems operational. Fuel cells also operate silently, making them ideal for indoor environments. Lastly, in the aerospace sector, fuel cells were first used during the Apollo missions and remain important for NASA's missions nowadays. A key advantage is the byproduct, which is water. It serves the drink water for the astronaut and for cooling spacecraft systems. Satellites also get benefit from fuel cells due to their long-lasting power supply.
Now, I will be discussing about recent advantages of fuel cells in daily life. My first point is about nanotechnology. Nanotechnology is transforming fuel cells by improving catalysts. For example, using platinum nanoparticles increases the surface area. Thus, it was speeding up reaction while using less material. Alright, platinum nanoparticles, which is also nanocatalyst in fuel cells, improve the efficiency of hydrogen oxidation and oxygen reduction reactions. For your information, this one-dimensional structure of nanowires facilitates excellent electron transport, which enhance the overall performance of the fuel cell. As you know, nano is the 10 to the power of -9, which means the particle is very tiny. As you can see in the picture, I am showing a part of length of nanowires, which shows the molecules are very tiny. My second point is about hybrid system. Hybrid systems combine fuel cells with other energy storage devices like batteries or supercapacitors. This will optimize overall performance. Now, the question is, what is the function of the fuel cells and what is the function of the battery of supercapacitor? The function of fuel cells is to provide continuous energy generations, while the battery or supercapacitor handles peak power demands and energy storage. Alright, these hybrid systems are especially useful in the applications like electrical vehicles. For an example, the real-world example is Toyota Mirai. Toyota Mirai uses this technology to improve efficiency.
So, the conclusion is, fuel cells provides a sustainable energy solution with high efficiency and environmental benefits, but their advancement is hindered by cost, durability, and infrastructure challenges. This is all the reference that we got from website, from journal, from book, and from YouTube video. That's all from us. Thank you for watching our video.